Hello and welcome to a new video. Today we're doing a 24 subscriber Q&A special. I'm here with Dan. Hi Dan. Hello. And today we're going to read your questions and answer them. Are you ready?
Yes.
Okay, cool. So the first question is from II Captain. It's funny because it's with I and this is about vision.
How do you know it's supposed to be?
Because that's the theme we set for this video. We asked you guys to send us questions.
You could have told me this beforehand so I could prepare. I've always wondered how the eye turns what you see into signals. Well, as you probably know, light is part of the electromagnetic spectrum, which is energy waves. And in your eye there are cells that can convert this energy into chemical energy and neural signals. Each cell is responsive to a certain small part of this energy, and thus only responds to a certain color of light.
Wow, you seem well prepared. Okay, let's move on.
I know my stuff.
Good job. Let's move on to the second question. It's from Slightly Receptive 2020. Slightly Receptive 2020.
Let's see what he asks. How does the eye send information to the brain? Well, that's easy. To start with, the presence of a stimulus is detected by the change in the firing rate of neurons. Following there's not one but two pathways from the eye to the brain, but they are not that important right now. What is important is two types of cells: the magnocellular cells and the parvocellular cells. The magnocellular cells are a bit bigger and they are sensitive to moving stimulus. They receive their inputs from rods. The parvocellular cells are a bit smaller. They are sensitive to form and color, and they receive their input from the cones.
Okay. I heard you talking about the pathways. Can you maybe explain them a bit more?
Sure. We have the geniculostriates and the tactopulvinar system. Or GS and TS for short, because those words are too long. The geniculostriates system, or GS, ends up in the striped cortex, one for each hemisphere. The name comes from the way, like, when you stain that part, it ends up being all layers. So, striped cortex. Layers 1, 4, and 6 receive their input from the eye on the other side of where the GS, or that part of GS, is located, and 2, 3, and 5 receive their input from the same side. This cortex combines the info from both the eyes, and segregates info from the parvocellular and magnocellular cells. Then we have the TS. And then we have the TS, which starts from the retina, then goes to the superior colliculus, to the pulvinar, and then to the parietal or temporal lobe.
Wow, that's a lot of difficult words.
Yes, thank you. It is magnocellular cells, and it is the basis of where things are in your visual field.
Nice. Want to go to the next question?
Yeah, sure.
Cool.
The signals get sent to the right part of the brain.
Let's move on to the third question. This one is from Heteromonculus. What a great name. Here you go.
He asks, how are shapes seen as shapes? Wow, what a good question. Well, there are neurons in your brain that only fire when a certain pattern of light reaches their receptive field. Likewise, there are also neurons in your brain that inhibit firing when a certain pattern of light reaches their receptive field. If these are combined, then you could in turn see shapes as shapes, because only those neurons are firing.
Sounds good. Want to go to the next question? Sure. Okay. Almost at the last question, but not yet. This one is from...
Or is this the last question?
No. There's one more.
Then we'll do the bonus question.
Let's go to the last question. This one is from From Retinane.
Retinane.
You wanna read it?
Yeah, sure. I mean, I have to. How does the brain know what is where in your visual field?
How does it?
How does it? Well, your brain obviously knows what's left and what's right because, like, left is being processed by the right, and the right side of the visual field is being processed by your left hemisphere. So that's an easy distinction. What the fuck are you doing? And then we go back to the geniculostriate system, because every cell in the GS has a receptive field in the retina. And the receptive field is what can be seen from that cell's viewpoint, basically. This in turn makes in the cortex a topographic map, which is a representation of the outside world. And then we have the corpus callosum to bind together between the left part of the GS and the right part of the GS. And then you know what is where in your visual field.
Sounds good.
Yep.
Nice.
Is that it?
Do you have time for... Oh, I don't have a watch. Do you have time for bonus question? You also don't.
I also don't have a watch.
That means we have time for bonus question.
Wow!
Let's go on. Wow! I have a question.
Nice.
Bonus question is from Optic Niasm.
Alright, let's see what he asks.
Go ahead.
Can you explain the blind spot? Why can't I see there? Well, it's actually pretty easy.
Hey, we have a blind spot.
Yeah, in your eye. It's where the neurons come together and like leave the eye. But because the way the eye is formed, the receptors, the photoreceptors of your eye are behind the neurons. And if there's one place where all the neurons leave the eyes, then it means that there is no place for photoreceptors behind the neurons, because there are neurons there. Which means that you have no photoreceptors there, which means that you can see there with them. Or,
But I can still see everything.
but you can still see everything because your other eye makes up for it.
Well, that makes sense.
Then that's it for our Q&A.
Thank you for watching. Don't forget to like, comment and subscribe on this video. We'll see you next time with another Q&A special.